we move now to the explanation of category D. So as already explained, the basic principle is exactly the same as J2601. There is no difference at all. So you will have, it's table based. So the ramp rate is fixed. And in the table, you will find a certain, it's either 100% SOC or a target pressure from the table. And the boundaries are +7 and then 1 megapascal per minute is a lower boundary. So all that remains exactly the same. And this is also how it is written in the -5. Actually, they refer to the light duty version and they just make some items where they say this has changed. So otherwise, yeah, it's written here, but it's the same as before. The basic principle is the same. So how will it work? As previously, you have to choose a table, but now there will be 2 lookup tables. So you have non-communication and communication. You have your fuel delivery temperature category. The D means that you can always go to -40. So this means -26 to -40 or -17.5 to -40. But then you need to choose the table depending on your TVL, the largest tank. These tables will have slower fueling than these tables. So in other words, if you do not receive any TVL in the optional data, then you will have to use these tables here, which are more conservative. So you choose a table. It gives you, for APRR, a temperature-based actual APRR in this line here, as you know. So for example, here at ambient temperature 25 degrees Celsius, and your largest tank, single tank, is less than 250 liters, and you have a T30 pre-cooling protocol, you will have 9.7 megapascal per minute. But at the same time, you are making a calculation, and what is new is this part here. So what is new is that you now take the FM value from the optional data and divide by 60. So if your vehicle says the maximum 60 grams per second, obviously nothing changes compared to how it was before. But if your vehicle wants to says that it's allowed to receive up to 90 grams per second, then it becomes 1.5 times faster. So for example, we have a 25 kilogram vehicle with 90 grams per second. Then you put this into the formula. Usually we always take 174 liters as V station D. And then the result is 12 megapascal. Imagine this is the same vehicle as this one. Then you take just the lowest of the two. So which means that it's not flow constrained. We will take the temperature constraint value, 9.7. Now, when I compare all these tables, so we have tables depending on temperature rating, T40, T30, T20, and we have tables depending on TVL, single tank size. And I compare them with the current APRRs. I come to all these tables here, depending on ambient temperature. So as you can see here, the table for in T40D, there is no difference between a single tank below 250 or above 250. So these two APRRs are identical. Of course, target pressure might change, but APRR is no difference. A second thing that we can see is that for because now in the past we had this 19.9 because of the 60 grams per second nozzle, and now this is increased to 22.2. So for very low temperatures in Scandinavia or so, you will have a benefit, and you can even fuel a little bit faster than the current one. If I look at the T30, initially there is no difference between small single tank or large single tank. It's between 10 degrees and 35 degrees. You have a little bit slower with if you have a single large tank. When the temperatures become negative, then there is again no difference. And it's even faster than the current one. And then for T20D, there we have a large impact. So T30, not so much impact, very small difference. But for T20D, the impact is all over the line. And of course, APRR is quite slow when you use the -5 version. So my personal impression is that T30 might be a quite good one. Of course, you still have your flow constraint APRR. Huh? This is only temperature constraint APRR. So if we look at the flow constraint APRR, there, if I took as an example European climate conditions, and I took as an example between, imagine your climate is between -10 and +35. Then again, I think 30D for the flow constraint value is a sweet spot, because here, these are the lines which we already had from our temperature constraint value. And here you can see the curve of the flow constraint value. So this depends on the total volume of your vehicle. Now, I guess there will not be too many vehicles initially who are going to use D category protocol with the higher volumes. So actually you can ignore these values. But if you have medium duty trucks up to, let's say, 1,200, 1,400 liters, then actually you have here a very good value when you choose a T30. So T40D has higher temperature constraints, that is true, but above 500 liter, the flow constraint value has priority. And you can see that here. So T40D is between here 22.2 and this value for -10 degrees. So once you reach 500 liters, you are stuck to this value here, and you will always be lower than the temperature constraint value from the table. So with a single nozzle, APRR actual takes over from the flow constraint value below 1,250 liters. Or if you use twin nozzle fueling, it will be 3,000 liters. So in other words, yeah, you will have limitations with a single mid-flow if you go above 1,250. Another new item in the D category is called the fueling time indicator. And also the minimum mass flow has changed. So this is a new mandatory item. During the fueling, you have to put this FTI at a 0 or a 1. A 1 means that you are fueling, and a 0 means that you have an intended non-fueling time, such as for a buffer change or a leak check. Then, like in the United States has many of these stations, and they're mandatory, these leak checks. So then you must set the FTI indicator at 0. So when the FTI is 0, you should stay below 1% of the FM value. We already knew this. It used to be 0.6 grams per second. However, for the FM90, it's 0.9 grams per second. That is considered as no fueling, actually. You are allowed to play a little bit with this in the sense that, for example, that you are allowed to put sometimes so if you look carefully, this red line is the same line actually as this red line. And here you have a momentary pause during the fueling, as you can see, but you are allowed to keep the ramp rate going up. So to keep FTI as 1, that is allowed. So even though the red line is the dispenser pressure, by the way, yeah. So the red line is dispenser pressure. You can see there is a small pause, but you can still consider it as going continuously up. But this can only be done on the condition that you do not drop below the minimum flow rate for more than 10 seconds. And this minimum flow rate depends on your total tank size. What is not allowed, absolutely not allowed, is that you put somewhere FTI 0 while actually the dispenser pressure is going up, and that you do have a fueling. That is not allowed. This FTI is also used in SAE J2601-5 4.3 in the United States and Canada, which they are using for checking the stations. And that's the only difference. So between J2601D category and the -5D category is this FTI, and the fact that we have these different APRR depending on TVL. And I will pause. I think this was the end. Yes, it's the end. So I'll pause a little bit.
Yeah, take a glass of water, and Klaus will raise a question or giving a comment.
Yes, it's actually a question. I'm also learning a bit from this, so
Great.
Thank you very much, Vincent. Vincent, can you give an explanation why H35 FM60 is not included in this? Because this SAE J2601-5 category seems to cover all known nozzle receptacle connections except for the H35 FM60, which happens to be the only one that SAE haven't standardized yet.
For why H35 is not included?
Yeah, H35 F60.
F60. Yeah, it's one of my questions for Steve.
Okay, so you also wonder.
I already put that on my question list.
Okay, I back up on that question to Steve. So
yes, okay, I will tell him that I'm not the only one asking this. Yeah, yeah, that's true. Yeah, because I heard that there are quite a few stations in Europe that will, for heavy duty vehicles, that will be equipped with a normal H35 nozzle. Yeah, I heard the same.
Thank you.
Ignacio is the next one. Please, Ignacio, go ahead.
Yes, have a question on the FM signal or the FM data field. There is FM60, FM90. Is there a possibility of communicating of an FM value that is in between? For example, I tell the vehicle charger station my FM is 85, something like. I mean, I could imagine a vehicle with an 4mm bore receptacle, but with some I don't know, check valve or piping that has a high pressure drop. So the manufacturer says I don't want it, or my limit for refueling is 85 grams per second, for example. Is it foreseen?
Initially, our plan was to do anything between FM60 and even FM120. Even though there might be only a 4 millimeter design receptacle. And of course, this would create a much higher pressure drop. But that was the original intention. And in the end, we decided, for the sake of simplicity and also in order to reduce the testing, etc., to choose only for FM60 or FM90.
Okay.
This was taken in consensus after many discussions.
So it means if the vehicle communicates FM 85, it will be taken as an error, right?
Yeah, it will go to FM60 in that case.
Okay. Okay. Thank you.